Let's have an exercise to test what we learned from the guiding questions and start to think like a scientist. The diagram shows an experiment that studies the effect of various treatments on the shoot growth. The shoots are illuminated with the unilateral light from the right hand side. Obviously, the setup A is the control setup, which is used to compare with other setup to study the effect of various treatment on the shoot growth. From setup B, the tip X is covered by the light-proof tin foil. For setup C, the lower part of the shoot is covered by the light-proof tin foil, so that's why they will not receive any light. These two setups are very important to show that which region, X or Y, is responsible for the light detection. For setup D, the tip is separated from the body by jelly block, and from setup E, the tip is separated from the body by the mucus plate. In these two setups, you would better consider the nature of the jelly block and the mucus plate. Then we obtain the result. At this moment, I would like to introduce a good practice of the examination skills. Mark down all the growth conditions of the shoot in the setups A, B, C, D, E. Normally, there are three possible cases for us to observe. Possible results 1. Growth with bending. Possible results 2. Growth but without bending. Possible results 3. No growth and no bending. So that's why you can see that from setup A, growth with bending, and for setup B, only growth strictly, and for setup C, growth with bending, and for D, growth with bending, and for E, no growth, no bending. So at least you can mark down all the conditions first, so it can help you to answer the question easily. Question part A. This question is a very typical one to ask you for description and explanation for the growth response of the shoot in setup A. So you can see from the diagram, the shoot A is the intact shoot and being not covered by the tin foil. Meanwhile, it's receiving the unilateral light illumination. It's just like the example we had when I talk about the 4 guiding questions. Since the question itself doesn't tell you the growth response, you have to mention the growth response of the shoot A first. This description carries 1 mark. Then you have to explain why this growth response happened. What you need to recall are the guiding questions. The shoot A grows and bend towards the unilateral light source. It carries one mark for the description. And then for the second step, we need to talk about the migration of the auxin. It is because the unilateral light causes the migration of auxin from the illuminated side to the shaded side. And then there is an uneven distribution of auxin. There is a lower concentration of auxin in the illuminated side than the shaded side. Since an increased concentration of auxin promotes the growth of the shoot, so the shaded side will grow faster than the illuminated side. One reminder for this type of question, there are 2 possible patterns to construct your answer. You can talk about the result first and then explain. It's just like what I did in this question. You can also explain what was happening in the whole setup first, then talk about any observation of the growth response finally as the conclusion. It's just a matter of presentation. Question B. Based on the experiment result, deduce whether region X or region Y is responsible for light reception. Explain your answer. You can find the 3 main components in the question. Firstly, what you answer must be related to the experiment result. Any setup should be chosen for our analysis. They should be setups A, B, and C. Mainly, we can compare the results of setup B and C for our conclusion. Secondly, you need to deduce whether the region X or Y is responsible for detecting light. Thirdly, explain your answer. Just like part A, you can surely tell me whether region X or Y is responsible for detecting light first, then do the explanation part. So what you can see is that first step, we need to compare the result of B and C. It's known that when covering region X with the tin foil will preventing bending, while covering region Y does not have such effect. And the second step is that we try to explain no lateral migration of auxin caused by the unilateral light and no bending can occur when the region of detecting the light is covered by the tin foil. The last step, we need to draw the conclusion. So region X is the region of light detection. Last but not least, part C. State why growth and curvature occurs in D but not in E. You can also see the three components in the question. Firstly, we have to state the observations in setup D and E. Secondly, when talking about the growth response, we have to talk about it in terms of growth and curvature. Thirdly, explain why this growth response happened. Therefore, you have to recall the nature of the jelly block and the Milker plate. How do the jelly block and Milker plate affect the auxin movement from the tip to the region of elongation of the shoot? Firstly, you need to talk about it. In both setups D and E, the auxin produced by the shoot tip migrates from the illuminated side to the shaded side. In setup D, the jelly block is permeable to auxin. In setup E, the shoot tip is separated from the region of elongation by the impermeable Milker plate. So that's why in setup D, because the jelly block is permeable to auxin, the auxin produced at the shoot tip can pass down to the region of elongation. The last step, we are going to draw the conclusion. There is an increased concentration in the shaded side will grow faster than the illuminated side, lead to unequal growth and bending in the shoot. And in setup E, auxin, because they cannot reach the region of elongation, so finally no growth or bending, no growth or curvature can occur. So you can see that because the question is asking setup D and E at the same time, so that's why you cannot only talk about one setup. Okay, no matter you only talk about setup D or only talk about setup E, that's not complete. So that's why when you do the comparison between these two setups, for example, the jelly block and the Milker plate, you need to compare them at the same time. And then for the auxin movement, can the auxin pass down to the region of elongation? In setup D, they can, and in setup E, the auxin cannot pass down to the region of elongation. And then you also need to compare them and finally explain the experiment result. We can construct our answer in the very logical way. Okay, so that's the end of this video. So if you have any question, please leave it below. I will answer you as soon as possible. See you next time. Bye bye.